Good morning, good afternoon. A warm welcome to all our attendees today from across the globe. Thank you so much for joining us for this webinar today on effective Hadoop cluster management. I'm Lisa Glenn, your host and presenter for today's session, and joining me as the featured speaker is Vinay Kaur, Hadoop expert from Impetus Labs. So let's go ahead and have a look at what today's session has in store for us. So we know that Apache Hadoop is an open source, Java-based free software framework that enables the processing of huge amounts of data through distributed data processing. We also know that correct provisioning and management is the key to ensure a successful Hadoop cluster environment. In our session today, we're going to discuss addressing the challenges associated with cluster setup, sharing, and management. We'll further talk about some of the benefits of automated setup, centralized management of multiple Hadoop clusters, and quick provisioning of cloud-based Hadoop clusters. And let me just start with a quick Hadoop overview for you. The Hadoop framework offers the required support for the data-intensive distributed applications. It also engages multiple nodes for processing the large amount of data stored locally on an individual node. Now, the results produced by the individual nodes are then consolidated further to generate the final output. Hadoop provides MapReduce APIs and works on the Hadoop-compatible distributed file system. A Hadoop cluster has multiple nodes, each having a specific role which runs some particular services on it. The master node runs the name node and job tracker services. The secondary master runs secondary name nodes, service, and the slave nodes execute data node and task tracker services. Now, the Hadoop subcomponents, such as HBase, Hive, Pig, and Zookeeper, have specific uses and benefits associated with them. Now, normally, these subcomponents are also used along with Hadoop and therefore need setup and configuration too. The Hadoop cluster setup is usually carried out by the Hadoop developers or administrators. And in the actual production system, it's common to have a Hadoop cluster size ranging from about 30 to 500 nodes. Setting up a standalone or a pseudo distributed cluster is relatively an easy task. But on the other hand, setting up and managing a production-level cluster in a truly distributed environment really requires significant efforts in configuration and is also very tedious and really a time-consuming task. Different cluster modes call for different kinds of configurations. Now, you can see on your screen now there's a table depicting the commands and settings that change due to the change in cluster modes, further adding on to the complexities. So taking this discussion just a bit forward, I'd like to talk about the pain areas associated with Hadoop clusters. We believe that the pain areas fall under the various categories that you can now actually see on your screen. We're going to talk in detail about the operational challenges, followed by cluster setup, where we'll also share with you the challenges and solutions for setting up a cluster on-premise as well as on the cloud. And afterwards, we're going to discuss the management of configurations, nodes, services, jobs, and users. The Hadoop compatibility and mode-aware operations is the next area that we're going to take up, and then we're going to move on to sharing and related challenges. But before all that, let's determine what's been missing from the current way of working with the Hadoop clusters. Let's go ahead and try to understand all these dimensions one by one. And we're going to start with automation, which actually plays a crucial role in quick and error-free execution of activities. And though automation has been around for decades, using it in the Hadoop environment is actually a relatively new practice. The automation doesn't necessarily have to be complex or sophisticated. In its easiest form, it could be a shell script that automates a multi-step activity. Now, it's applied to make the execution non-interactive so that it continues to work on the assigned activity autonomously and without any human intervention. A good automation solution should not only facilitate automation, but also handle the failures with panache. It also should have the capability to identify the problem areas that may result in failures as well as the problem source. And in a scenario where multiple activities are running in sequence and a particular activity fails, then it should enable the non-dependent subsequent activities to continue without any interruptions. Now, moving on to the next item, which is setup support around bundles. Now, in its simplest form, the Hadoop bundles are just simple tar files. They need to be extracted and require setup and initialization, which can either be manual or automated. Apache Hadoop bundles, especially the tarball, doesn't have any support set up around them. Now, the missing attribute with the current way of working with Hadoop is a user-friendly interface. To solve that, what's required is an alternate interface to perform all or some of the key activities that is likely to improve our Hadoop working. This interface could really be anything from a desktop application GUI or a web-based interface which is accessible from the browser. Moving ahead to the next critical attribute, which is built-in support for cluster management capabilities. The current cluster management offers limited functionalities, and the operations need to be carried out manually from a console-based interface. Furthermore, there is no feature presently that enables management of multiple clusters from one single location. The user actually needs to change the interface or log into different machines in order to manage the different clusters. Plus, the support for monitoring and notifications is also missing. The existing monitoring support is only at a framework level and is used to ensure sufficient data replication. Now, through this feature, the master node can blacklist the node or include it again in the cluster. However, the administrator does not get this information unless he actively visits the cluster health status page. Now, let me go ahead and explain the need for active alerts and notifications. Say you issued a command to change the state of a service or to submit a job. Now, in order to determine the status or outcome of your request, you would be required to go to the console or interface where you submitted that command. Now, I am quite sure that you would have preferred if you'd received periodic updates regarding your request progress status, completion, or failure without having to actively go seek it. Okay, now moving on to cluster sharing, which is entirely missing at the user level. If we take a look at some of the big data solutions like Greenplum or a commercial solution such as Aster Data, you would find that they do offer all the features that we're showing as missing here. However, there are some players offering tools and solutions that address those pain areas. Now, before we discuss those, I would like to ask you all a question. As per your experience, what is the most critical factor missing from working with Hadoop clusters? Now, your choices are automation, setup support, especially on cloud, user-friendly interface, cluster management capabilities, monitoring and notification support, and provision for cluster sharing. You have now a total of 30 seconds to answer, and you can choose multiple options if you'd like. Okay, it looks like we've received the responses, and it seems the majority of our audience is swaying towards automation and lack of setup support on cloud as the missing critical factors. Vinay, what's your take on these results?
I agree with audience that automation is the key missing factor. If we think carefully, then we will find that automation internally plays an indirect role across all the other mentioned dimensions to make them work. Setup options could be one closest competitor, but that is anyway a one-time activity per cluster. And being one-time in worst case, that could be managed anyhow. And here also automation is one of the integral part of setup support itself. Hadoop, even after having comparatively low cost and proven solution, large user base, and a lot of installations, still the rate at which Hadoop is catching up, especially for production use, is relatively slower than expected. In my personal opinion, probably automation is the reason. Missing automation introduces various pains and complexities for cluster setup and management. In this session, we will see how automation, when combined with other dimensions, can help to make your experience of working with Hadoop environment a better one.
Great, thanks Vinay. I now want to talk about the problems and solutions of Hadoop cluster setup, management, and sharing. And we're going to go ahead and start with the operational troubles. The first challenge that I'm going to discuss here is manual mode of execution that requires attended user interaction. Now, this consumes a lot of time and is very error-prone. But it can be easily resolved by introducing automation, as it will enable unattended, quick, and error-free operation. And let me go ahead and explain how. Essentially, every command has two parts. One is the command itself, and the second is the parameters, which could be optional. Now, automation ensures that the right commands are being submitted, whereas the parameters may or may not be correct, as they are all keyed in by the users. However, we have an option to validate the user inputs so as to ensure that only the right parameters are being used. For automation, one needs to identify the parameters that may typically change as per operations or installations. This kind of parameter-driven, highly configurable automation also prevents the possible human errors that could occur. Now, on to our next operational challenge, which is using the console-based interface, which has several limitations of its own, such as serial execution and interactive working. You can resolve this problem by adopting a user-friendly GUI as an alternate interface that supports automation as well as runs several activities in parallel. We believe that automation and alternate interface together can really address the operational challenges. Together, they just offer better working environment and provide activity status or progress updates. We'll now talk about the problems and solutions of setting up Hadoop clusters. Now, as we shared with you before, manually setting up a mid to large size Hadoop cluster in a distributed environment is a difficult task. Factors such as cluster mode, Hadoop vendor, version, bundle type, and the target environment further add to the setup complexities. Cluster setup requires careful execution of predefined actions where even a minor error or omission due to manual intervention can result in a major setback. Now, while simple automation can handle this problem, some actions may still require user intervention, for example, accepting the license agreements. Bringing in smart automation into the picture enables quick setup of the cluster in a hassle-free and non-interactive manner. The entire functionality is provided through a highly configurable alternate user interface, offering just a simple click-based cluster provisioning through friendly and configurable UI. It utilizes context-aware automation based on the provided inputs. Aware of the given context, automation executes the activities in the required order and provides an error-free and operational cluster with necessary components installed. Basically, in short, automation is the key for quick and successful provisioning of cluster. Now, moving on to the setup environment. In the next slide, I'd like to highlight the differences between setting up a cluster on-premise and over the cloud. Now, you can see the table on your screen now, and you'll notice a few additional activities that are required to set up a cloud-based cluster. And let me just go into some of their details. So, for cloud-based clusters, we're required to launch and terminate the cluster instances. However, the hardware, operating systems, and installed Java versions are mostly uniform, which may differ in the case of on-premise deployment. And for on-premise deployment, you would need to set up passwordless SSH between the nodes, which is not required in the cloud setup. However, the setup of Hadoop ecosystem components remains the same regardless of the cluster setup environment. Now, in the next slide, Vinay is going to share with you how you can quickly provision cloud-based Hadoop cluster. Vinay?
Thanks, Lisa. The cloud-based Hadoop cluster provisioning on surface appears to be challenging, difficult, and time-consuming. But as Lisa shared with you in the last slide, it is more or less similar to setting up an on-premise Hadoop cluster. There are some additional activities that are required for setting up cloud-based cluster machines, which can be easily handled by using automation. I think the issues and complexities come in due to the manual operations, which involve steps such as accessing the cloud provider interface to launch the required number of nodes, providing inputs for key pair, security settings, machine configuration, and image. You would then need to open or unblock the required ports, manually collect the individual IPs, and then add them to the Hadoop slave files. After using the cloud cluster, you would also need to manually terminate all the machines sequentially by individually selecting them on the cloud interface. While this may be easily carried out if the cluster size is relatively small, but performing all these activities manually on a big cluster may lead to numerous errors. Alternatively, bringing automation in the picture can help to save time and efforts. You can incorporate automation by adding simple scripts or using cloud provider specific exposed APIs. You can alternatively use generic cloud APIs such as JCloud, SimpleCloud, LibCloud. You can even create your own MapReduce cluster launch on Amazon using EC2 Web Service APIs without using Elastic MapReduce to offer the same functionality in a customized manner. Cloudera CDH2 scripts also enable launching instances on cloud and then help in setting up Hadoop over launched nodes. Somewhat similar is the case with Vir, which uses JCloud APIs.
Thanks, Vinay. I'm now going to talk about the problems and solutions of effectively managing Hadoop clusters. Now, the key challenge here is the lack of appropriate functionalities to manage the cluster. You can address this problem area by adopting a dedicated and sophisticated support for various cluster management capabilities. Now, these may include managing configuration, nodes and services, jobs, keys and users, and providing adequate support for monitoring and notifications. All these functionalities can be supported through an alternate user-friendly interface which automates the cluster management activities. This is an active and really a user-friendly approach that offers updates on the progress, notifications for various events, and change in status to the users. Plus, the mode of receiving these updates can be customized by the user or administrator as per the preference. We'll talk now about another key challenge related to the underlying technology here. Now, Hadoop as a technology is still evolving and really has not reached complete maturity yet. And this factor in turn gives way to numerous challenges. A few of them include the API's differences across versions, their on-wire compatibility, and interoperability of multiple versions and their respective components. Sometimes, some given configurations just may not be supported in certain versions, and problems can also arise due to multiple vendors and vendor-specific features. There can also be complexities related to bundle formats, such as tarball and RPM, as their setup and folder locations differ. The cluster modes are another factor that demands suitable changes for configuration and command execution. Now, security is available as a separate patch and needs customized configuration. Issues can also crop up due to the vendor-specific solutions such as SPOF, HA, and compatible file systems. Now, Vinay, you are the resident Hadoop expert here at the Impetus Labs. Can you share with us how we can address all these technology-specific problems?
Sure, Lisa. At the outset, I want to share with you that we can find workarounds to partially address the compatibility challenges. A complete solution may not be possible as these problems are due to the underlying technology. You can address the compatibility problems by adopting a Hadoop cluster management tool which can give users an option to replace the incompatible bundles with the suitable ones. Now this will ensure that all the nodes within the cluster have the same version of Hadoop and respective components installed. The other factors such as version, vendor, bundle format can also be handled using any HCM tool that facilitates context-aware component management support. This tool can keep track of files and folder names, command changes, and location differences. For using vendor-specific features, I would suggest that you should either use vendor-specific interface or some compatible solution.
Great, thanks, Vinay. That was very helpful. And now, let's move on to the problems and solutions of sharing the Hadoop clusters. So what exactly do we mean by cluster sharing? Well, essentially, it stands for sharing the clusters with your development and testing teams. So what is the problem area? First, the way that these clusters are shared, and second, the purpose of sharing the clusters. Currently, we share the Hadoop clusters by sharing the credentials of cluster machine with the users. Here, you would need to make some amends on the cluster security and setup complexity. And let me just explain this. You would either share the credentials of a common user account or create separate accounts for each user with whom you are planning to share the cluster. So, say you share the common user account, and in this case, the system is exposed at this user account, which may have some exclusive privileges that is now available to all the users with whom you've shared the credentials. Now, in the second approach, you would create OS-level separate user accounts on each node of cluster with restricted privileges. Now, obviously, this is a complex and very time-consuming task and really just does not make sense. So, how do we address this problem? Well, we suggest that you use role-based sharing of the cluster through the alternate UI. Now, through this way, the users will be created at solution level and not on the OS level. And they'll be relatively easy to manage and control through admin interface on the solution. Furthermore, the solution-specific roles can be created and assigned to the user accounts in order to restrict individual user access to specified functionalities. So, ladies and gentlemen, these were the challenges and solutions of effectively setting up, managing, and sharing the Hadoop clusters. And now, as we move on to the next part of the presentation, we're going to discuss how and how much the available Hadoop cluster management tools can help. We believe that these tools help immensely. They offer quick turnaround and enable you to create new clusters quickly and as per your specifications. The tools offer automated setup, thereby leaving no room for errors. They also help to minimize total cost of operation by reducing the time and efforts required for cluster setup and management. Plus, the HCM tools provide integrated support for all your requirements from one place and one interface. The tools can also help to set up a cluster for testing the application across different vendors, distributions, and versions, and then benchmarking them on different configuration, load, and environments. They help in analyzing what is the impact of cluster size against different load patterns, and then enabling launch and resize of the cluster on the fly. Coming up on your screen, you can see the activities that an ideal Hadoop cluster management tool should provide in the area of setup, management, and sharing. Now, apart from the tasks that are mentioned here, I'd like to also share that the HCM tools should help in adhering to industry's best practices, such as configuration, separation, separate Hadoop users creation, sharing the cluster without any security compromise, ability for the cluster to restart, and the awareness of the network configuration. So on your screen, you can see some of the tools that are currently available for the effective setup, management, and sharing of the Hadoop clusters. I'd like to highlight one in particular, and that's Impetus's Ankush, which is our web-based solution that supports the intricacies involved in cluster setup, management, cloud provisioning, and sharing. One notable feature that I'd like to mention here is that Ankush offers centralized management of multiple clusters. Now, this is very helpful, as there really won't be any need to change the interface or log into different machines in order to manage those different clusters. I now want to ask Vinay to tell us about this solution in a bit more detail. Vinay?
The diagram that you now see on your screen describes various functionalities offered by beta version of Ankush. So in the node management area, the solution through its web interface supports listing of existing nodes as well as addition and removal of nodes by IP or host name. This solution supports cluster setup in all possible modes. It also performs context-aware auto-initialization of configuration parameters based on cluster mode. The initialization support includes services, configuration initialization, initial node addition, and initial job submission. Additionally, it also supports multiple vendor versions bundles for Hadoop ecosystem components. For cloud, the solution supports launch and termination of entire Hadoop cluster for both heterogeneous and homogeneous configurations. Ankush can support all the required cloud-supported operations from its own UI, and therefore you would no longer need to access cloud-specific interface. It also supports centralized management and monitoring of multiple clusters. The individual cluster-based operations can also be managed using same interface from same location. Ankush facilitates support for reconfiguration and upgrade of Hadoop and other components, management of keys, users, configuration parameters, services, and monitoring. User management supports multiple user roles. It allows role-based access to various cluster functionalities. Only the admin role-based users can perform the operations that affect the state of cluster. The setup of cluster components and predependencies like Java and passwordless SSH are also done in an automated fashion.
Thanks, Vinay. I'd now like to take just a little bit more of your time and share some key features of our unique offering, Ankush. You can use this solution to set up and manage the local clusters as well as the cloud-based clusters. The solution is a web-based application and is bundled as a WAR file, which makes the solution deployable even at the user level. Now, additionally, Ankush offers anytime, anywhere access to the cluster functionalities through its web-based interface. Our solution is cloud independent and is not coupled with any particular cloud, thereby giving its user the option to launch the cluster on other compatible clouds. Ankush offers you a way to quickly apply the configuration changes across all the clusters to leverage the performance benefits. And it actually helps us reduce the cluster setup time by 60%. It also enables bundle setup optimization across cluster nodes using parallelism and bundle reuse. And now I'd just like to reiterate some of the key points that we were able to cover in today's session. First, automation facilitates quick and error-free execution of activities. It can be applied to make the execution non-interactive and just free from human intervention. It can also be used to save extensive time, efforts, and costs involved in cluster setup on cloud. All you need to do is add simple scripts or use cloud provider-specific exposed APIs. Now, another key takeaway is that adopting a user-friendly GUI as an alternate interface can help you in addressing cluster sharing problems, and it will also support automation and really helps execute activities in parallel. I'd also like to stress here that Hadoop is still evolving and has yet to reach maturity. So you can only address the Hadoop compatibility issues, and even with that, only partially. Lastly, using a suitable Hadoop cluster management tool can greatly address the issues and pain areas associated with cluster setup, management, and sharing. Okay, it looks like we've actually started to receive some questions from the audience, and I'd just like to remind you that you can use the chat panel on the right to ask your questions. But before I take up those audience queries, I'd just like to take a moment to introduce Impetus Technologies. Impetus is a leading technology and R&D services provider with a strong focus and established thought leadership in the area of large data analytics and high-performance computing. We built top-tier expertise and offer consulting and professional services in technologies like Hadoop, numerous NoSQL DBs including Cassandra, MongoDB, Membase, and a range of commercial MPP products and ETL BI analytics tools. Our expertise spans the domains of large data management, cloud computing, data analytics, mobile, SaaS, testing, social media, web technologies, performance engineering, open source, among others. So it looks like we have started to receive some of those questions, and the first question that someone asks is, how much time does it take any tool to set up a cluster in an automated way? Ankush or any other tool? Vinay, what do you think?
Well, that's a good question. The exact time taken by any tool is difficult to answer as it involves different variable factors like the size of cluster that we are planning to set up, whether the cluster is a cloud-based cluster or on-premise cluster. As already mentioned earlier, that cloud cluster involves additional steps of launching cloud nodes, and in order to proceed further, all the launch nodes must be ready in running state before any other further activity could be carried out on them. Also, the time of launch plays a role because in the peak load time, it takes much longer to finish the launch step on cloud. It also depends on total number of Hadoop components that are selected for setup, like Hive, Pig, HBase, or any others. It also depends on the mirror selected for downloading these components and the available bandwidth for download. But to give you a rough idea of the required time, 5 to 6 node cloud-based cluster from scratch to cluster running state, which has 3 to 4 Hadoop components installed, it may take just 20 minutes to install, and for local cluster, it will take 12 to 15 minutes, which includes downloading the components over a reasonably good speed connection.
Great, thanks, Vinay. Okay, there's another question that came in, and this person would like to know, is it possible to launch Hadoop cluster on any cloud other than Amazon? What do you think?
Well, as far as in terms of tools, cloud cluster launching capability is concerned, I would say yes, it would be possible. But the main problem lies with the data storage, that is availability of Hadoop compatible file system on other clouds, like Amazon S3 is there in case of Amazon EC2. The similar kind of Hadoop compatible file system is presently missing on other clouds. So launching cluster on other clouds is not difficult at all, but then either you will have to move data there or use Amazon S3 from that cloud. And in either case, you will have to pay for the data transfer charges for much huge data transfer.
Okay, great. Another person asks, is load-based auto-scaling of cluster, is that supported by any solution? What's the answer to that?
For cloud-based cluster, currently it is supported only by Amazon EC2 in its Elastic MapReduce. And it is just because it's being its native service, it is able to utilize monitoring information and enable auto-scaling based on that. For other solutions, both in cloud and local environments, currently scaling is possible, but that needs to be carried out or initiated manually, not automatically. I would also like to highlight that load-based auto-scaling might not be required always, since Hadoop jobs are of non-real-time nature, and in some cases, it may lead to unnecessary increase in operational cost. Auto-scaling could be useful only in cases where you have some specific SLA cases on time of completion for the jobs.
Okay. Now, Vinay, someone would like for you to explain what kind of differences exist in Hadoop setup when bundle type or vendor changes occur.
Okay, let me quickly tell a few of them. Tarball bundles require name node formatting, while Cloudera RPM bundles doesn't require name node formatting. Cloudera bundles require to run services as a non-root user. Commands, bundle name and the download URL totally differ when it's a case of RPM based bundle setup and Tarball setup. For Cloudera, the Hadoop download bundle itself differs depending on the required cluster mode. Folder locations also differ. In Cloudera case, Conf folder is physically located at different location and a link of it exists in Hadoop Home. Cloudera allows start and stop of individual services, while Apache allows them as a group of HDFS and MapReduce. Bundle setup optimizations are also the possible case that differ across different bundle types.
Okay, great. Looks like we have another question, and this person would like to know how using solutions parameter configuration becomes an easier task. What do you think, Vinay? How can that be a little easier?
To understand this, let's divide the configuration requirements at two different times. Once during setup. During setup, auto-initialization helps to run setup in an automated way without human intervention. And for management purpose, the features offered for configuration management allows you to update the configuration distribution across different nodes automatically. They also allow a user-friendly interface for filtering, searching, the parameters, sorting them, and editing them online using the GUI interface. Also, it also saves you from the continuous cycle of locating the parameters across different files, editing those parameters, and saving them manually through console.
Okay, great. Thank you all so much for those great questions. There were some other questions that were asked, and we're going to be addressing those questions through a follow-up email. Now, some of those questions include, how does Ankush differ from Cloudera Enterprise Management Tools? Someone would like to know, do we have any details about how to start and use BigTop? Also, someone would like to know, can you provide more details about using WIR for deploying Hadoop clusters in EC2? Again, all those will be addressed in a follow-up email to you. I'd just like to thank you all now for your time, and we really hope that this discussion was a learning experience for everyone and will add value to your big data initiatives. Now, if you have any questions on what we talked about today, please email us at inquiry@impetus.com, or you can visit our website, bigdata.impetus.com. Once again, thank you so much for joining us for today's session. Have a good day.